Hello everyone. For today we will be solving Edexcel IAL Pure Mathematics 4 Jan 2025 paper with detailed explanations to make you understand each and every question as smoothly as possible. So without further ado, let's dive right in. So in the first question, they have given us a curve with an equation which is y equals 4 over x plus 2. Now the region are bounded by the curve, the y-axis and the x-axis, and the line with equation x is equals to 8 is shown in figure 1. Now this region R is rotated 360 degrees about the x-axis. So this has been rotated 360 degrees about the x-axis, so which means that the shape of the volume should look something like this. It should look something like this. Now we just need to find the shape of the volume basically. Alright. So we know that the volume is equals to pi integrate the lower limit is 0 and the upper limit is 1. It is 8 and y squared dx. This is the formula for volume. Now we can write this as 0 to 8. So y squared, that gives us 16 over x plus 2 whole squared. Now you can integrate this in several methods. One of them is the reverse chain rule, which all of you have learned in the Pure Mathematics 3 course. But in this case, we will use integration by substitution as it is much easier and it is a part of P4. So we will take the substitution u equals x plus 2, and the first step would be to differentiate this and make dx the subject. So I can say that dx is equals to du. And as you can see that these values, the upper limit and lower limit, are given in terms of x. These are values of x. So these are the values of x. Now we just need to find the values of u. So when the value of x is 0, the value of u is 2. And when the value of x is 8, the value of u is 10. So we can rewrite this integration as v equals, so v equals pi integration 2 to 10, 16 over u squared and du. We can replace dx by dx with du. So this should give us a value of negative 16 over u. So now we just need to substitute the values of the upper limit and the lower limit. So the final value would be 32 over 5 pi. So it's 32 over 5 pi units cubed. So that is the answer for this question. Now moving on to the second question. They have given us an equation of a curve C, and we need to find an expression for dy over dx in terms of x and y. So this is a part of implicit differentiation. We need to apply the rules of implicit differentiation for this. So let's first differentiate this term. The derivative of this term will be 3. And if we differentiate the second term, this would be 10y times dy over dx. And then we need to differentiate this term. So we need to apply the product rule in this case. So this will be 4x squared dy over dx plus 8xy plus 8xy. So that's the answer for this. Now let's move on to the right hand side of the equation. So for the right hand side of the equation, the we need to find the derivative of this part. So we know that we have a formula, which is, let's say we have a value of a to the power x. If we differentiate this, we will get a to the power x ln a. So this is a formula. This is given in the formula booklet as well. So this will be 10 2 to the power x times ln 2. And the derivative of this term will be 0. Now let's make dy over dx the subject. So this will be the final answer to the first part of question 2. Now let's move on to the second part. The curve C cuts the y-axis at the point P. Find the exact value of the gradient of the tangent to C at P. So the curve C cuts the y-axis at the point P. We know that at y-axis, the value of x is 0. So if we substitute x equals 0 into this equation, we will get 5y squared equals 10 times 2 to the power 0 plus 35. So it's 5y squared. So from this, we will get the value of y. So there are two values of y, plus and minus 3. But we know that y is greater than 0, so y cannot be negative. Y is a positive value, so y is equals to 3. So we know the coordinates of point P, which is 0 and 3. Now we need to find the exact value of the gradient of the tangent to C at P. So if we substitute this coordinate into the dy over dx equation, we will get the gradient of the tangent. So for this part, x is equals to 0 and y is equals to 3. So that would give us 10 times 2 to the power 0 ln 2 minus 3 minus 0 divided by 30 plus 0, which is basically 30. So if we simplify this, this should give us, we know that 2 to the power 0 is equals to 1. So this is 10 ln 2 minus 3 divided by 30. So you can keep it like this, or if you want, you can simplify it further by writing it like this. 1 over 3 ln 2 minus 1 over 10. So that is the answer for this question. Now moving on to the next question. Given that the binomial expansion in ascending powers of x of this term is this. So first of all, we need to expand this expansion up to x squared. So in order to apply the formula, which is 1 plus nx plus dot dot dot, the first term needs to be 1. But as you can see that there's 4 in this part, so we need to take 4 as common. So if we take 4 as common, we know that there's a power of negative half of 4 plus ax. So if we take 4 as common, the power will be negative 1 over 2. So it's 1 plus a over 4x to the power minus 0.5. So this is equals to 3 times 1 plus a by 4 x to the power negative 0.5. Now we can apply the formula for the expansion. So it's 1 plus mx So this can go on forever, but we can stop in this part because we just need the coefficient of x squared and also b and -1/4. So now if we simplify this, this will give us 3 minus 3 over 8 ax and plus 3 over 128 a square x squared. So this must be equal to this expansion, which means that the coefficient of x squared must match. So -1/4 must be equals to -3/8a. So we can say 3/8a equals 1/4. So from this part we can find out the value of a. So the value of a is 2/3. Now I guess we need to find out all of the values of b and c and a. So this is the value of a. Now we just need to find out the value of b. We can say that the value of b is equals to 3. So b is equals to 3. And c is equals to 3/128 a square. C equals 3/128 2/3 squared. So it's basically 1/32. So there was a slight problem. It's that I did not multiply. So I did not multiply this value of 3 with this equation. So this will be 9. So that's 9. So this will be, won't be 1/96. This will be 1/32. So that is it for the first part of the question. Now moving on to the second part, state the range of values of x for which this expansion is valid. So for this expansion to be valid, we know that for an expansion which looks something like this, for this expansion to be valid, the modulus of ax must be less than 1. So it must be less than 1. So which means that a/4x must be less than 1. So the modulus of a/4x must be less than 1. And a divided by 4, that gives us a value of 1/6. So we can just take this 1/6 and move it to the right hand side of the equation. So it will give us a value of modulus of x is less than 6. So that is the answer for this part. Now moving on to the third part. For the expansion, find the coefficient of the term in x cubed. Now we know that the x squared term looks like this. Now if we want to find out the coefficient, the x cubed term should look something like this. So it's minus 0.5 minus 1 and 0.5 minus 2 divided by 3 factorial times a cube divided by 4 cube, and the value of 4 cube is 64. And all of these values should also be multiplied by 3 also, because there's 3 at the front of the expansion. So this gives us a value of -5/1152 x cubed. So the coefficient is this value. So that is it for question 3. Now moving on to the next question. So in the first part, the volume V of a spherical balloon is increasing at a constant rate of 70 pi centimeters cubed per second. So we are given the value of dV over dt, which is equals to 70 pi centimeters cubed per second. Now we need to find out the rate of increase of the radius of the balloon. Now since they have given us dV over dt, which means that volume of the sphere is somehow involved in this problem. So we first need to find out the volume of this sphere. We know that volume of sphere equals 4 over 3 pi r cubed. Now then we need to differentiate this term. So dV by dr should give us 4 pi r squared. Now we need to find out the rate of increase of the radius of the balloon, which means we need to find out dr over dt. So we can write dr over dt as dv over dt multiplied by dr over dv, because as you can see that these dv's cancels out each other, so we are left with dr over dt. All right, so the value of dv over dt is 70 pi, and that can be written as 1 over 4 pi r square. So the pi's cancels each other out, and if we simplify this equation, this gives us a value of 35 over 2 r square. Now I guess we need to find out the value of dr over dt when the radius is 5 centimeters. So we're basically finding out dr over dt when the radius is 5, when the value of r is 5. So it's 35 over 2 times 5 square, which is 25. So it's basically 35 over 50, which is 0.7 centimeters per second. So that is the answer to the first part of your question. Now moving on to the next part of the question. The depth of water in a cave is being monitored. The rate of increase in the depth of water. So dH by dt is given. Now initially the depth of water was 4 centimeters, which means that when t is equals to 0, h is equals to 4. 5 hours after monitoring began, the depth of water was 6 centimeters. So when t is equals to 5, h is equals to 6. And t hours after monitoring began, the depth of water was t centimeters. So when t is equals to uppercase T, the value of h is 10. Solve the differential equation to find the value of t, giving your answer to one decimal place. So this is part of the second order differential equation from P4. So we know that dH over dt is k over h cubed. dH over dt is k over h cubed. Now in order to find an equation for h in terms of t, first of all we need to separate the variables. Let's bring the h variables on the left hand side of the equation. So that's h cubed dh, and this is k times dt. So this is the first step. And now once you have separated the variables, the second step is to put an integral sign on both sides of the equation. So this will be h to the power 4 over 4 is equals to kt plus c. Now we need to find out the value of k and the value of c. One of the information we know that when t is equals to 0, h is equals to 4. So h is 4 to the power 4 divided by 4, and t is 0. So the value of c is 4 cubed. So which is equals to 64. Then we need to find out the value of k. We have another information, it's that when t is equals to 5, the value of h is 6. So the value of h is 6 when t is equals to 5. So that's 5k plus 64. So from this equation we can find out the value of k. So the value of k is 52. Finally, we have an equation which looks something like this: h to the power 4 divided by 4 equals 52t plus 64. Now I guess we need to find out the value of t when h is 10. So the value of h is 10, so that's 10 to the power 4 divided by 4 is equals to 52 capital T plus 64. So the value of t is around 46.8 hours. So that is it for this question. Now moving on to the next question, we need to find the integral of x squared and e to the power 4x. Now as you can see that you cannot apply the reverse chain rule for this. So for this specific term, we need to use the integration by parts, or I usually prefer the DI method. It is still the integration by parts, but DI method is actually recommended. So if we look at the DI method, there are two columns, D and an I column, and there will be a plus, minus, plus. You need to start with a plus sign and repeat it with a minus and plus and minus and plus. So this can go on forever. Now, which term you need to put in the D column and an I column? To understand that, we need to simply understand that if we differentiate x squared repeatedly, at one point it will give us a value of 0. So we need to take this value and substitute it into the D column, and the rest of the part will be in the I column, which is e to the power 4x. Now if we differentiate 2x squared, we get 2x, and if we differentiate 2x, we get 2, and if we differentiate 2, we get 0, and differentiating 0 will give us 0, so this will continue on forever. Now let's integrate e to the power 4x, so that's 1 over 4 e to the power 4x, and this is 1 over 16 e to the power 4x, and that will give us 1 over 16 times 4, which is 64 e to the power 4x. You can stop your iteration in this point, in this part. When you see a 0 in the D column, you can stop the iteration. Now the next thing you need to do is that write the integral, which is x squared e to the power 4x and dx. This is equals to, then you need to cross multiply the values. So it's basically x squared over 4 e to the power 4x, and there's a minus sign at the front for 2x, so this will be minus x over 8 e to the power 4x, and the next thing will be plus 1 over 32 e to the power 4x. Now you need to always remember that if you want to stop the iteration, the last thing you want to do is that multiply these last two corresponding values. So that's minus 0 multiplied by 1 over 64 e to the power 4x, and then you need to integrate the product. Now as we know that anything multiplied by 0 will be 0, so this will be your final integration, and you need to add a plus c at the front. So this is the answer for part A, and I suggest you all to follow the DA method instead of the normal boring textbook method, DI method is much more efficient and it's way much more time saving than the boring traditional method from the textbook. And moving on to the next part of the question, we need to use partial fractions and algebraic integration to show that this value is equals to ln k. So first of all, integrating this seems impossible, but we need to use partial fractions for this. So instead of moving on with the integration, let's first divide this fraction into partial fractions. So we know that 2x plus 11 over 2x plus 1 and 2 minus x. 2x plus 1 and 2 minus x. This can be written as a divided by 2x plus 1 plus b divided by 2 minus x. And if we simplify this, this will give us 2x plus 11 is equals to a times 2 minus x plus b times 2x plus 1. So you can find out the values of a and b in two different ways. First way is following the traditional method is that by comparing the coefficients of x and the coefficient of the basically the constant. And the next thing you can do is that the clever method is called actually the finding out the critical values, taking critical values of x. So first of all, in order to make this 0, it's somewhat of an elimination method. It's kind of a cheating algebra, if you can say. So you need to, first of all, you need to make this 0 in order to make this variable a, in order to eliminate this variable a. So if you want to make this 0, which means that you need to substitute the value of x as 2 into this equation. So if I substitute x equals 2 into this equation, as you can see that this becomes 0. So the value of b is actually 3. And then what you need to do is that you need to make this part of the equation 0. So if I substitute x equals negative 0.5 into this equation, this becomes 0. So let's substitute that. So 2 times negative 0.5 plus 11 equals a times 2 minus 0.5 plus b times 0. So from this we can find out the value of a. So the value of a is actually 4. So this is a much more easier method than the traditional method, which is the comparing the coefficients and finding out the values. That takes up a lot of time. So now we can say that the integral, wait, let me just look at the expression. So that's 4 and 7. So this can be written as 4 over 2x plus 1 and plus 3 over 2 minus x. Dx. Now we can easily integrate this. So the integration of this would be 2 ln 2x plus 1 minus 3 ln 2 minus x. So it's 4 and 7. So if you're still confused about where these values came from, this minus 3 and 2, let me just simplify this for you. If an expression is in this format, f prime x divided by fx, and if you integrate this, you should get a value of ln fx and plus c. This formula is not given in the textbook nor the formula booklet. You need to memorize this and just take a screenshot of this if you want. So the thing is that if you want to write this in the form f prime x divided by fx, this is the fx. If you differentiate this, you get 2. So so in the numerator, there should be a value of 2. So if you take 2 as common, so this becomes 2 over 2x plus 1. So the integral of this would be 2 ln 2x plus 1. And for the next expression is that if you differentiate the denominator, you get -1. So -1 should be in the numerator part. So in order for that, we need to take -3 as common. So we get -1 divided by 2 minus x. And the integral of this would be -3 ln 2 minus x. So I hope this clears your confusion. So this is equals to 2 ln 15 minus 3 ln 5. Well, this is supposed to be a modulus, right? So that's modulus. So 2 minus 7 is -5. So the modulus of -5 is 5. Minus 2 ln 9 plus 3. So overall, this should give us a value of ln 8 over 45. You need to keep your answer in this format. So that is it for this question. Are you still stuck in chapter 1? While exams race closer, watched a dozen videos but still receiving the same marks in tests? Well, it's not you, it's the method. Let's fix that. Now welcome to Exam Essentials, where every second counts and every session hits. We usually offer 2 signature courses for O and A level students. The number 1 is the High Impact Crash Course. It is launched 5 to 6 months before every exam session. Whether you're a 2025 or 2026 candidate or any future sessions, this course is your fast track to astonishing results. And the number 2 course is our complete 1-year course. It is designed for 2026 and 2027 candidates or beyond. Now to know more, check the description box or text us directly on WhatsApp or our Facebook page. Stop struggling, start scoring. Your true potential is waiting. The time is now. Now moving on to the next question. This is a question of question from chapter 1, which is proof by contradiction. Now the statement they have given us is that if n square minus 4n plus 5 is even, then n is odd. So the first step we need to do is we need to make an assumption. So we need to assume the complete opposite, that n squared minus 4n plus 5 is even. So n is also even. Now, there might be a question in your mind that says that if the assumption is the complete opposite of the given statement, which means that I could have written it like if n squared minus 4n plus 5 is odd, then n is even. But as you can see that this gives us the same meaning. Is that if n squared minus 4n plus 5 is x, then n is y, which means if one is odd, then the other one is even, and vice versa. If one is even, the other one is odd. So it actually gives us the same meaning. So there is a base variable for this question. The base variable is n. So we need to take the complete opposite in our assumption for the variable n. Or you could have also written it like this, that if n squared minus 4n plus 5 is odd, then n is also odd. Now in this case, we assume that n is even. So if n is even, we can write n as 2k, because this is divisible by 2. So which means that I can replace n squared minus 4n plus 5 as 2k whole squared minus 4 times 2k plus 5. So this is actually 4k squared minus 8k plus 5. So we need to prove that this is not an even number. So if we take 2 as common, we get 2k squared minus 4k. We cannot take 2 common from 5, so we need to leave it by the side. Or you can write this expression as 2 times 2k squared minus 4k plus 2 plus 1. So it's up to you which one you prefer. So I usually prefer this one because this one is much easier. And then you need to write a statement by the side which is not even or which is odd. So this contradicts our assumption. So if n squared minus 4n plus 5 is odd, is even, then n is odd. Then n is odd. So that's the conclusion of this question. And that's it for this question. Now moving on to the next question, we need to use the substitution x equals 4 sine theta to find the exact value of this integration. So first of all, we need to differentiate the substitution equation. So if we differentiate this, so dx over d theta, that would be 4 cos theta. And then what we need to do is that we need to make dx the subject. So that gives us 4 cos theta times d theta. All right. Now the next thing we need to do is that these are given values of x. We need to find out the values for okay, so we need to find out the values for theta. So we know that when x is 2 root over 3, we can find out the value of theta using this equation. So the value of theta is pi over 3. Now when the value of x is 2, we need to find out the value of theta, which is sine theta. So the value of theta would be sine inverse 0.5, which is pi over 6. So we can rewrite this integration as integrate. The upper limit is pi over 3 and the lower limit is pi over 6. And we can write dx as 4 cos theta d theta. So that's 4 cos theta and d theta divided by 16 minus x squared to the power 1.5. So that's basically 16 minus x squared. We know that the value of x is 4 sine theta. So the value of x squared is 16 sine squared theta. So it's 16 sine squared theta and the power is 1.5. So now we just need to carry out this integration. So it's pi over 6 and pi over 3. So it's 4 cos theta divided by, and we can write this as 16 cos squared theta because because cos squared theta is equals to 1 minus sine squared theta, and there's a 16 at the front. So we can write this as 16 cos squared theta to the powered cos squared theta to the powered 1.5. So this will give us a value of 16 to the power 1.5 is 64, and 2 times 1.5 it's 3. So that's 64 cos cube theta. So that's 64 cos cubed theta, d theta. So this is equals to 4 divided by 64 gives us 1 over 16. So it's 1 divided by 16 cos squared theta. Now we can also write this as, wait, I'll just show this to you. So we can also write this as 1 over 16 sec squared theta. And the integral of sec squared theta is tan theta. So that's tan theta divided by 16. And the lower limit is pi over 6. The upper limit is pi over 3. So it's basically, so this gives a value of root over 3 by 24. This is the exact value. So that is it for this question. Now moving on to the next question. This is a question from chapter 7, I think. This is a vector question. All right. So the line L has equation this, and point A has coordinates -2a and 4, and both of these points, point A and point B, lies on line L. And point B has coordinates this. Now, first of all, we need to find out the value of the constant A and the value of constant B. So this is pretty simple. We just need to substitute the coordinates into this equation. Since both of these coordinates lie on the line with equation this, so we can say that -2a and 4 is equals to 4 lambda plus 2 and 2 lambda minus 1 and minus lambda plus 3. So first of all, in order to find out the value of a, we need to find out the value of lambda. In order for that, we can just equate one of these two pairs of values. We just need to equate the corresponding values. So from this, we can find out that the value of lambda is equals to -1. Now let's equate the mid value, which we need. So we can say that a is equals to -2 and -1, which is equals to -3. So that is the value of a. Now let's substitute another coordinate, which is the coordinates of b, into this equation. So if we substitute the coordinates of b, same thing for this. We first need to find out the value of the scalar parameter, which is the lambda. So let's equate these two values. So we can say that lambda is equals to 2 for the coordinate of b. Now let's equate this value. So we can say that b is equals to 4 times 2, which is 8. 8 plus 2, that is 10. So the value of b is 10. So that is it for the first part of the question. Now moving on to the next part of the question, we need to find out the AB vector. So we know that the AB vector can be written as the position vector of B, which is OB vector, minus the position vector of A, which is the OA vector. So the OB vector is actually this part, which is 10, 3, and 1. So that's 10, 3, and 1, minus the OA vector, which is -2, -3, and 4. -2, -3, and 4. That's 12 and 6 and -3. That's 12, 6, and -3. This is the AB vector. Now the next part of the question is the point C has coordinates this. Find the size of the angle CAB. So basically, let's say that this is line L, and let's say this is point A and this is point B. Let's assume that point C lies somewhere around this part. So we need to calculate this angle theta. So we can use the scalar product rule, which is the AC vector multiplied by the AB vector is equals to the modulus of AC times the modulus of AB cos theta. So first of all, we need to find out the AC vector. We can say that the AC vector can be written as OC vector minus the OA vector. So the OC vector is given, which is 4, 7, and minus 2. So it's 4, 7, and minus 2. And the OA vector is also given, which is minus 2, this one, minus 2, minus 3, and 4. Minus 2, minus 3, and 4. So the AC vector is equals to 6 and 10 and minus 6. So that is the AC vector. Now we just need to substitute the values into the scalar product equation. So the AC vector is 6, 10, and minus 6. So it's 6, 10, and minus 6. And the AB vector, we have found out the AB vector in the previous question, which is 12, 6, and minus 3. So that's 12, 6, and minus 3. So that is equals to the modulus of AC vector. The modulus of AC vector would be 6 squared plus 10 squared plus negative 6 squared, that is 36. So it's root over. And the modulus of AB vector, which is 12 squared plus 6 squared plus negative 3 whole squared, which is 9, times cos theta. Now multiplying these two vectors is fairly easy. So that's 6, 12 plus 10 times 6 plus minus 6 times minus 3. So that is the multiplication of these two vectors. And this is equals to 2 root over 43 multiplied by 3 root over 21 cos theta. So from this equation we can find out the value of theta. So the value of theta is around 33.7 degrees. So that is the answer for this part. Now moving on to the next part of the question. So in the next question, the point D lies on the line L so that the area of triangle CAD is twice the area of triangle CAB. So let's assume that point D lies on this part. So there will be two triangles, CAB and CAD. As you can see that the perpendicular height of the triangle remains constant. We know that area equals half base height. So if area doubles, we know that the height remains constant, which means that the length of the base should also double. So I can say that the AD vector is twice of AB vector. Twice of AB, but there is a twist. There should be two possible positions of D. So D can lie either on this part or on this part. So if D lies on this part, which means that AD is equals to twice of AB. But if D lies on this part, which means AD is equals to negative 2 of AB, because the direction is different. So which means this will be plus or minus 2 AB. So it's plus or minus AB. So that's 24, 12, and minus 6. 24, 12, and minus 6. So that's AD vector. Now we can say that the AD vector is equals to the OD vector minus OA vector. We need to find out the value of OD vector. So OD vector is equals to OA plus AD. So first of all, let's take the positive value, which is 24, 12, and minus 6. And the value of O is constant, which is minus 2, minus 3, and 4. So it's minus 2, minus 3, and 4 plus 24, 12, and minus 6. So this gives us a value of 22 and 12 minus 3, which is 9. That's minus 2. So this is one possible position of point D. Let's find the other one. Oh, we know that, so it's minus, oh wait. The OA vector is constant, that is minus 2, minus 3, and 4. But the AD vector may change. Let's take the negative value for now. So it's minus 24, minus 12, and plus 6. So this gives a value of negative 26 and negative 15 and 10. So this is the other possible value for the position vector of D. So these are the only two values. So that is it for this question. Now moving on to the next question. We have a curve which has parametric equations, x equals 2 cos 2t and y equals sine cube t. Now, use parametric differentiation to show that dy over dx is equals to this. Okay. So for parametric differentiation, we can say that dy over dx is equals to dy over dt times dt over dx. All right. So dy over dt is 3 sine squared t cos t. 3 sine squared t cos t, because the derivative of 2 cos 2t is equals to 4 sine 2t. So it's 4 sine 2t. Oh, wait. Oh, okay. So the derivative of y is 3 sine squared t and cos t divided by the derivative of this, which is negative 4 sine 2t multiplied by 1 over negative 4 sine 2t, and we can write sine 2t as 2 sine t and cos t using the trigonometric identity. As we can see that these two cancels out and this one, and the power becomes 1. So this is equals to negative 3 over 8 sine t. I guess this is the answer. Okay, now moving on to the next part, we need to find an equation for line L. We need to show that the equation looks like this. So line L is the tangent to C at point P. At point P, the value of t is pi by 6. Now we just need to find out the value of x and the value of y. So when the value of p is t is pi by 6, the value of x is 1 and the value of y is 1 over 8. Now let's substitute t equal pi by 6 into the dy over dx equation. In that way we will get the equation of the gradient of the tangent. So it's minus 3 by 8 sine pi by 6. So the gradient is negative 3 over 16. So the equation will be y minus y1. The value of y1 is 1 over 8 is equals to the gradient multiplied by x minus x1. x1 is 1. So if I make y the subject, this becomes negative 3 over 16x and 3 over 16 plus 1 over 8 plus 5 by 16. Now let's multiply this whole equation by 16. So that gives us 3x plus 16y minus 5 equals 0. So this is the answer to this question. Now moving on to the next question, the line L intersects the curve C again at the point Q. Using algebra and showing detailed reasoning, find the exact coordinates of point Q. So if these two graphs intersect, which means I can substitute the individual values for x and y into this equation. So the value of x is 2 cos 2t. So that's 3 multiplied by 2 cos 2t plus 16 multiplied by sine cube t minus 5 equals 0. And we can write cos 2t as 1 minus 2 sine squared t. 16 sine cube t minus 5 equals 0. So this gives us 16 sine cube t and minus 12 sine squared t plus 1 equals 0. Now if we solve this equation, we will get the values of sine t. So one of the values of sine t is negative 1 over 4 and the other value is 1 over 2. Now let's make t the subject. Now the problem is that if we want to make t the subject, there will be infinite values of t. We do not have a range. We do not have an exact domain. Plus, the value of t is negative for this part. So let's just keep it like this. And for this part, the value of t is pi over 6, which we do not need because we already know that the pi over 6 is where the point P lies. So you can just keep this in the bracket. So if the value of sine t is negative 1 over 4, let's find the value of x. So we can say that x is equals to 2 times 1 minus 2 sine squared t. So that's 2, 1 minus 2 multiplied by sine squared t. So negative 1 over 4 whole square, which is 1 over 16. So that gives us 7 over 4. Now let's find out the value of y. So y is written as sine cubed t. So that's negative 1 over 4 whole cube, which is equals to minus 1 over 64. So the coordinates of the point is 7 over 4 and minus 1 over 64. So this is the coordinate of q, the exact coordinates of q. So that is it for this question. So I hope you guys enjoyed the video so far and understood everything clearly. Be sure to like, subscribe, share, and leave a comment. And I will see you guys in the next video.